Okay, so let's look at how to find work of one force or several forces if there are. All right, so let's look at how to find work done by one force or several forces if there are several forces involved. So the classical formula for work, the long version of it, is force times distance times cosine of theta. The direction of force doesn't matter. Not when you're plugging in force as it is. So for example, if you're finding for work of gravity and you know that force of gravity is downward, that does not matter. You're not going to multiply mass by negative 9.8 or negative 10. You're just going to take mass times 9.8 or times 10, and that will be your force, or force of friction. You just use force of friction as is. You don't have to put a minus in there or anything like that. Distance is also not a vector, so it doesn't matter whether the object is moving left, right, up, down, sideways, whatever. You just take force as it is, absolute value or magnitude, times distance, and then you're multiplying it by cosine of theta. Now that is when direction comes in, because that angle is between which way the force is applied, so between the force, and which way the object is going, so velocity. So you need to look at your free body diagram and see what angle force and velocity make. And then you're going to take that angle and plug it into your cosine. And in your calculator, it needs to be set in degrees. You will see the value of cosine of theta. And I usually use the angles that you are familiar with, 1690. I mean, not, well, 90. Some forces make a 90-degree angle, but 60, 30, those are quite memorable. So example 1. Here we have the work of a force. That's the force that we're looking for. We're looking for work of that force. And as you see, the object is moving to the right, the force is to the right, so the angle between those two is going to be 0. Cosine of 0 is 1, so that's easy. So you'll end up with just multiplying force times distance, because velocity is in the same direction, so distance is indicated as delta x or d, if that makes it easier for you. So since the cosine of angle is 1, I can just do F times d. So let's say force is 5 newtons and distance is 2 meters, then we just end up with 10, and the unit for work, as you remember, is joules. The same example, only force is now to the left. So if you look at the angle between velocity and force, it's going to be 180, and cosine of 180 is negative 1. So if before it was 10 joules because they were in the same direction, now it's negative 10 because they are opposite each other. Now, the third example, we have force making a 30-degree angle with the direction of motion. So the same formula, force times distance times cosine of 30 in this case, and we end up with 8.6 joules. So far so good, I think. Here's another example where we have an incline involved, and the incline is making a 30-degree angle. Notice that just because you see the degrees, it doesn't mean that you're going to plug those degrees in the formula for work. Because in the formula for work, it's just the angle between the force and velocity. And as you see, velocity and force do not make a 30-degree angle. If you continue this force vector, you end up with a 90-degree angle and then 90-degree triangle. And so therefore, this angle, which is indeed the direction and force, that's the angle in question. And so therefore, it's a 60-degree angle. So since we're looking for the work done by gravity, if the mass of this block is 2 kilograms, the gravity we're talking about is 19.6 if you care about sig figs, or it's just 20. I'm going to use 10 for g, so it's easier to plug in. So 20 for gravity, 5 for distance, because the incline's length is 5 meters, and cosine of 60, which is the angle between the force and direction of motion. So that yields us 50 joules. All right, in the next example, I'm going to explain how to find network. So as you see, we have several forces. We have 3 altogether, because now the incline has friction, and mu is 0.2. And so I'm showing all 3 forces. I'm showing gravity, and we already remember that it's 20 newtons. Then we have force of friction, and we have normal force. Now, not all 3 forces are going to be doing work, because since we have cosine of the angle between force and velocity, normal force here makes a 90-degree angle, so therefore cosine of 90 being 0, normal force will not perform any work on this block. So what we are going to do is find all works separately and then add them as numbers. If work ends up negative, then we'll just add negative number to the sum, and we will end up with what is called net work, the work done by all forces on the object. So the work of gravity is still 50 joules because nothing changed. It's still 5 meters, it's still 2 kilograms, the angle is still 60 between displacement and, or direction, velocity, and the force is 60 degrees, so mgl for the length times cosine of 60, so that's 50 joules. Now, to find the work of normal force, we would have to find normal force. And just, you know, to reiterate how to find it, you remember that force normal is counteracting the y component of gravity. The y component of gravity is found as mg cosine of 30, because if you draw a line here, you will see that this y component of gravity is making the same degree as the incline. It's making 30-degree angle with the actual force, with the actual gravity. So the y component of gravity is mg cosine of 30. So that's normal force that I have in square brackets here, times displacement, which is 5, times cosine of 90. This cosine of 90 gives us 0, so that's 0 joules of work. Now, force of friction is directed up the incline. Force of friction, kinetic friction that is always directed opposite to motion. So with force of friction, you always end up with a 180-degree angle between the force and the velocity. As you remember, force of friction is found as mu times normal force being mg cosine of 30. And so you end up with mg cosine of 30 times 5 times cosine of 180. Cosine of 180 gives us negative. And then when you do mg cosine of 30 times 5, you end up with 17.3. So we have 17.3 joules of work. And so then, to find net work, I add all those three numbers together. 50 plus 0 plus negative 17, and I was lazy. It's 17.3 actually, so 32.7 joules is our net work. Now, another way of finding net work is finding net force and then plugging that force in the big work formula. So instead of just force, it's going to be net force times distance times cosine of the angle, and usually net force is either at 0 degrees or, which is rare, it might be making 180 degrees. So in our case, our net force is going to be in this direction. So normal force doesn't make any difference in the direction along the incline. So what is making a difference is the x component of gravity. So x component of gravity is down the incline, force of friction is up the incline, so they're opposite each other. So when we're finding net force, we're going to end up with mgx minus force of friction. So mgx minus force of friction, since mg itself is 20 and it's opposite a 30-degree angle, it's going to be 10. Force of friction is mu mg times cosine of 30, as we saw in the previous example. It yields you 3.45 newtons. So 10 minus 3.45 newtons gives us 6.55 newtons of net force. And net force is down the incline, velocity is down the incline, so angle between them is 0. So you do 6.55 times 5 equals 32.7, which is exactly the same number as we got in the previous example when we found each work separately and then add them all up together. So hopefully this will help you understand or be able to find work of each force and work of net or net work of all the forces that are acting on the object better. Thank you for watching.